Hello, my name is Ebrahim Alkhayat. My ID is 2015-00449. This is a final demonstration for the CLP project. My project is Hybrid Cloud Infrastructure, which is being sponsored by Alkhayat Computers Middle East. The project proposal is to design and create a hybrid cloud infrastructure that will be consisting of two parts. The first part is the cloud-based network that will be created on the AWS. And the second part is the emulated network that will be created on the EVE-NG emulator. Both networks will be connected via secure connection. In addition, security measurements will be added to control and secure the traffic between both networks. For the objectives, I have two that is related to ACME objectives, which is creating an AWS cloud network and activating cloud security services to the AWS cloud. ACME main idea for the project was to have only an AWS network with some security services activating on it. However, to fulfill the CLP requirements, I need to work on networking project as it's my major. Polytechnic consider AWS as MIS project. That's why I have added a whole networking part and integrated this part with the AWS cloud. For the parts of the project proposal, all parts have been completed and it will be all explained in the next slides. This slide represents the AWS part. As you can see, on the left, I have categorized the technologies, or let's say the components that I have used in this part. And on the right side, we have the AWS whole design. As you can see, we have networking components, security components, and some additional components. The design of the AWS part consists of two VPCs, a primary VPC and a secondary VPC. Both VPCs will have public and private subnets. Primary VPC will be used mainly for the EC2 instance, which is the workstation that we will be using in this cloud. On the secondary VPC, we will be having a database and an EC2 which will represent the web server. Both VPC will have internet connectivity through the internet gateway, and both they will be connecting to the transit gateway. The transit gateway will provide connectivity from VPC primary to VPC secondary, and also it will provide connectivity to the EVE-NG part, as it will go through the VPN connection to the customer gateway to the EVE-NG network. As for the security components, we have three security services that will be activated in the AWS part. The reason for choosing these security services is that Guard Duty will be dealing with the AWS account security monitoring by offering continuous monitoring of the AWS account and workloads to protect against any malicious or unauthorized activities to the AWS account. For the Amazon Inspector, this is an automated security assessment service that help improve the security of the applications that have been deployed on the EC2 instance. And finally, AWS Detective is an automatic collective log data service that can collect any data from the AWS resources which is related to the security issues, to investigate and analyze them to have a detailed information about the security issues or malicious activity. The reason for choosing these security services is that Guard Duty will be handling the AWS account security level. Amazon Inspector will be handling the EC2 security monitoring level. For the Detective, any findings that Guard Duty finds about the security issues can be investigate with the AWS detective. As for the additional services or components, we will be having Route 53, which is the DNS service, a web server, and a database. This is the AVNG part. For the networking components, I will be using Cisco routers and Cisco switches. For the security components, I will be using Cisco as a firewall. As you can see on the right, we have the design for the AVNG part. I have came up with this design as the old project for the ACME that was assigned to me is to create a network for the Bahrain Defense Hospital. I have checked the Bahrain Defense Hospital website. I have saw that they have 14 divisions in there. That's why I have created 16 divisions, 14 for the original divisions and 2 additional divisions. Maybe it will be added in the future. As you can see, the structure of the design is a hierarchical model. We have core, distribute, and access layer to the network. For the security, as a firewall will be placed between the internal network of the AVNG and between the edge router that is connected to the internet cloud. Traffic will be monitored and controlled by using ACLs and zone-based to specify the inside and outside interfaces. For the internal routing, I will be using OSPF as a routing protocol to connect all divisions together, and BGP will be used only in the edge router for the VPN connection between AVNG network and AWS cloud. Starting the demo with explaining the AWS account or the AWS design. Quickly I'll go through it. We have 2 VPC, primary VPC and a secondary VPC. Each VPC will be having private and public subnets. They will be divided into 3 availability zones. A primary VPC will have 2 availability zones. A secondary VPC will have 1 availability zone. The reason for doing that is that in case one resources or multiple resources in one availability zone went down, or the whole availability zone went down, you have the availability zone in another location. Let's say the other availability zone is available for you in case of the failover. Going to the AWS console, as you can see here, we have the 2 VPCs that we created before, primary VPC and the secondary VPC. They are both available, and you can see here this is the IP address that we are assigned to it. If you click on one, you can see the details down below for the VPC. Inside the VPC we have created the subnets. These are the subnets for the VPC. By default, when you create a subnet, AWS create the subnet as a private subnet. To make it public subnet, you need to choose the subnet that you want. Right click on it and choose this, modify auto assign IP settings. You need to enable the auto assign for the IPv4 public IP address. If you enable this one, public IPv4 addresses will be assigned to any resources within the subnet. So let's say we create an EC2. EC2 will be having a public IPv4 address because of the subnet settings. As I said, to provide internet connectivity, you need to have internet gateway attached to your VPC. So this is the internet gateway for the primary VPC. As you can see, this is the ID for the internet gateway. The status of the internet gateway is attached, and it's attached to this VPC, which is the primary VPC. If it's not attached, you will see it like this, it's de-attached. This is for the second one, and also attached for the secondary VPC. Within the VPC subnets, we are having the EC2 instance that we created. If it's an instance in a public subnet, as this one, you can see that public IPv4 is already assigned. If it's a private subnet, you will see that there is no public IPv4 assigned to it, only the private IP address. Here you can see, if you click on one, you can see the detail of the EC2. This is the VPC ID, which is this EC2 is belong to which VPC. This is in the primary VPC and within the availability zone 2 private subnet. As you can see now, we are having the EC2 running, and this is an EC2 within the public subnet. Let's say if I ping google.com, there is a successful ping to google.com. This means that we have an internet connectivity through the internet gateway. Moving to transit gateway, as you can see, we have one transit gateway and it's available for us. To see the attachment to this transit gateway, you need to go to transit gateway attachment. As we can see, we have 4 attachments. We have primary VPC attachment, secondary VPC attachment, and the VPN attachment. And all to see the route for the transit gateway, you need to go to transit gateway route. You can see that this transit gateway has 3 routes: one for the primary VPC, one for the secondary VPC, and one for the test VPC. To verify that we have connectivity to both VPC, I will go to one of the instance. I have the instance now running. I will take the IP address for the another instance. Let's say I'm choosing this instance, which is the availability zone 3 public subnet instance, which is the instance in the secondary VPC. I will take the private IP address. As we can see, we have successful ping between the 2 VPCs. This means that the transit gateway is running and there is connectivity between both VPCs. Moving on to the VPN connection, we need to go to site-to-site VPN connection to see the VPN. As you can see here, we have the VPN, which is connect the transit gateway to the EVNG route, which is to the edge router there. And to see the tunnels that the VPN create, here are AWS create 2 tunnels by default. In case one tunnel went down, you have another one available. The tunnel now is down. The reason for that is EVNG network still not active yet. Still, I didn't start it yet. That's why you are seeing this as down. Whenever I start the EVNG network, you will see this one as up. As you can see, this is the EVNG network. I will not start all nodes. The reason for that is my PC does not have the enough resources to start all of them, while also running VMware with the Google Chrome for the AWS console. That's why I have only run this PC with this PC to verify the connectivity between the EVNG network and the AWS cloud. The EVNG network is designed as a hierarchical model design. This design provides us with efficient, fast, and logical traffic for the topology. As we can see, we have core layer, distribute layer, and access layer. Here we have the as a firewall as the bridge between the network and the edge router. We have the edge router, which is connected to the internet. The whole network uses the OSPF routing protocol as an internal routing protocol to provide connectivity. To verify this, I will ping from one VPC to another VPC. As you can see here, I have this VPC with the IP address of this, and this is the gateway, which is this one here down. I have the second VPC, which is here with the IP address of this, and this is the gateway. As I see, I already ping. I will do another ping. I'm pinging the other PC and the pinging is successful. This means that we have the OSPF running successfully.
As for the security, we are having as a firewall. As a firewall, it will specify the interfaces that connect to it into zone-based interfaces, inside and outside. Inside zone is our EVNG network, and the security level for it by default is 100, which is the maximum level. The outside zone is for the edge router that's connected to the cloud, and the security level for it by default is 0, which is the lowest level. In ASA, the inside traffic can reach the outside traffic, but not the opposite. This means that the traffic that's coming from the core 1 and core 2 can reach the edge router, but not the opposite. This can be managed by applying ACLs to control the traffic. Without ACL applied on the interfaces, traffic cannot be controlled. As the design, we have two connections that will be inside, which is the connection that's coming from core 1 and the connection that's coming from core 2. And one connection will be as outside, which is the connection for the edge router. As there is two inside connections, when interfaces that having the same security level, they cannot connect to each other or reach each other. However, there will be command I will show you now, which can be used to make the inside zones with the same level. As we can see that we have two inside, they can connect to each other without the use of the ACL. This is the configuration for the ASA firewall. As you can see, this is the interface for the inside. We have the security level as 100. This is the interface for the outside. We have the security level as 0. This is the interface for the second inside, which is the security level is 100. To make both the inside interface connect or to reach each other, we need this configuration command. Same security traffic permit interface. This allow the inside interface with the same security level to be able to reach each other. For the ACL, I have created one ACL with the name AWS traffic, and I'm permitting here the AWS network to reach EVNG network, and here I'm doing the opposite. I'm permitting EVNG network to access AWS network. Also, there is an explicit deny at the end. It's hidden, it's not there, but by default it's there to deny any other type of traffic. And now moving to the edge router, as you can see the edge router now is running. This means that on the AWS side, on the VPN tunnel, the tunnel is supposed to be up. To verify, as you can see, the tunnels now is up because of the BGP, and there is routes coming from the tunnels. This is the routes that's coming from the EVNG side. As for the configuration for the router, for the VPN, all you need to do is to go to site-to-site VPN connection, and then you need to download the configuration for this VPN. You will end up with a file which contains all the configuration required to be added on the edge router. As you can see here, these are the configuration that have been downloaded from the AWS VPN. All these configuration are related to the Crypto ISACAM. Basically, Crypto ISACAM is the Internet Security Association and Key Management Protocol. This protocol is being used to establish Security Association, which is the SA. This is mainly used for the VPN connection. And these are all the information related to this protocol. Down below we have also the tunnels that have been created for the VPN. As I said, we have two tunnels. In case one went down, we have the another one. Also we have the BGP also neighboring between the AWS and EVNG. These are the BGP configuration. Here we are establishing neighboring between the AWS. Due to the time limit, I am unable to explain all these configuration in details, so any question related to these configuration will be answered later. To verify the status of the tunnels, I will issue some commands on the edge router. Issue the command show Crypto ISACAM SA. This will show us the tunnels that have been successfully created. As you can see, we have the tunnel destination, which is the two tunnels that have been created with, and this is the IP addresses for the AWS side. This is the outside IP address for the tunnel for the AWS, as it can be seen here. The source
This is the IP address for the interface that is directly connected to the internet. So the source for this tunnel is directly to go to the internet. As you can see, the status of the tunnel is active, and here the status of the tunnel is up. Okay, and another command to verify is the show IP BGP summary. As you can see, this command will show us the neighbor for the BGP protocol. These IP addresses is the neighbors for the AWS side tunnels. 33 is the AWS, and 34 is our IP address for the tunnel. This is also the same. 241 is for AWS. 242 is our side. To verify this, all you need to do, show run. You can go to the tunnels. As you can see, this is 242, which is our side, and this is 34 also, which is our side. To verify more, I will show you the routes that are coming from the AWS. Show IP route. See, there are two routes that coming from the BGP. 10.154.0.0. This is for the primary VPC, and for the secondary VPC 10.154.16.0. On the AWS side, you can go to the transit gateway route table. You will see the routes that are coming from the EVNG side. As you can see, these are the routes that are coming from the VPN, and see these are the routes for the subnets for the PCs, and all coming through the VPN. To verify the connectivity between EVNG network and AWS cloud, I will be pinging from this PC to the EC2 instance, which is this one, available to zone 1 in the public subnet. The IP address for it is 0.154.10.105. So as you can see, pinging is successful. I can also try from here to ping the IP in this PC, which is 172.16.02. Also, the ping is successful. For some security testing, I have created a whole new VPC with a new subnet, with a new EC2 with different IP address. As you can see, 192.168.100.19. This is an IP address which is outside the whole equation. We don't have this IP as in the ACL or within the route table in the EVNG. So I will try to ping from the EVNG to this IP address. As you can see, timeout. Also pinging from this side. As you can see, no ping is going. This means that the ping is timeout. As for the AWS security services, this is a guard duty findings page. As you can see, these are the findings that guard duty found. These are samples, ignore them. These are the real findings that the guard duty finds. If you click on one, you can see all the details related to this finding. This is a finding related to an EC2, which is an unprotected port. If you go down below, you can see the instance ID, which is the instance that they found this issue in, on which port exactly, the instance details, which is the private IP, the public IP. To go like in more detail about this open port and which IP that this port is dealing with, you can click on action and investigate. It will open for you the detective page for this issue that have been found, which is the finding. If you go on here, VPC flow detail, you will see that this port is dealing with two IP addresses, which is these. Also, if you click on the EC2 instance ID here, it will be showing, it will take you to the search also for the, or it will take you to the detective search page for this instance, like this. This is the instance. Here you can see the overall traffic flow for this instance, and also it will show you that this instance have two findings related to it, two security issue related to it, and they have been found on this date.